All right, thanks everyone for being here. I'm going to be talking about several GDB projects. I'm going to be rushing through many of these slides because I have a bunch of them. And from experience, if I I can drag this for a long while. So, but if I'm speeding up too much or being boring in some slide, please stop me and interrupt me and ask me things, or just tell me to move along. All right. Things I'm going to be talking about. Local remote feature parity, something that Ulrich presented in some Cauldron a while ago. It's still a project, it's still going. We still want to unify GDB and GDB Server. Debugging, I'm going to show you some things that we did last year, mostly Gary's work. Finer grained control of threads is something that I've been working on for a long while, which is about non-stop, all-stop, and merging all that and being able to control groups of threads. I'm going to be talking about the Sleep CC1 projects about using GCC inside GDB. This is the one that I'm not as familiar with as the others, but I think it's a very important project for the tool chain. So I'm showing you the status and what needs to be done and whatnot. Going to mention the C++ conversion, GDB's own C++ conversion. And I'm also going to show you the new support for consoles, for front ends, consoles inside front ends like IDEs, like Eclipse and other front ends. And that was something I think I removed from the talk, the scalability work, but still there. This is not in the correct order, so sorry about that. Right, I'm going to start with the consoles. And first, the problem is if you ever use Eclipse, you may not even notice that there's a console, GDB console widget inside Eclipse. It's very hidden. There's this console view, and then you select between different output consoles. There's the inferior output and the build output console, and there's a GDB console there. But it's very non-functional. So that's why there's been no investment in actually making it prominent. And the reason it's not very functional is that the way that GDB provides in order for frontend to build a useful console is very lacking. Frontends talk to GDB. Nowadays, the modern mechanism is through MI, called the machine interface. So normally people start here, at least hackers are used to starting GDB on the command line and typing commands, but there's a different method to start GDB. You pass it -IMI, and that it's a different interpreter. It's more machine-oriented. It's still text-based, but commands are parsable. And the idea was, if you want to build a console, to provide a console inside your IDE, you would wrap the CLI commands in an MI command. This is what an MI command looks like. It starts with a dash. And hand it over through MI. And GDB then knows this is a console command, interprets it normally, and then dumps the output, but wrapped in some kind of parsable tokens so that the front end knows, okay, this is the response, this is standard output, this tilt means it's standard output. So the front end needs to parse this and then display it in the widget, in the console widget. Right, so that's another example. So this has a bunch of limitations, like it doesn't have read line. You can't do command line editing, like up and down and moving, deleting words and accessing history with control S to go back in history, things like that. It's not possible unless the front end implements all of that itself. You can't do queries. I mean, if you do kill enter and you're running a program, GDB will say, are you sure you want to kill your program? That's called a query. You cannot do that through MI. It'll just kill immediately. So the thing is, GDB knows and needs to knows all about this and supports all of this already built in inside GDB. So the idea is, instead of forcing the front end to go through MI, just reuse the terminal widget that normally front ends already have. Like Eclipse has this widget that you can run commands inside. It runs a shell like bash. So you just reuse that widget and launch GDB with input and output redirected to that terminal. So it's just a normal GDB running on the command line, and create a separate channel for communication via MI to separate. Now you have two channels. So that's the idea. That's pretty simple. And all of that ends up being just one command in GDB. It's called new MI command. And it's like new MI and then the interpreter to run. And then the TTY, the PTS, of where the MI communication will happen. And that's simply it. I mean,
does it have to be a TTY?
No. It currently has to be a bidirectional file. But there's no reason for that. It's just, this is, I've been doing this in collaboration with the Eclipse guys. And the Eclipse already spawned a TTY for MI. So it was just, you know.
Could probably just be a name pipe even.
Could be a name pipe, anything. Or it could even be split files, like input and output, like 3 parameters in our output. It's just no one did that. Right, and that's it on the changes visible to the front end and to the user. Of course, internally, what this meant was that there's a bunch of global state in GDB. If you have a look at GDB, GDB is very fond of globals. And now you need to find all of those that are relevant for this channel, like the file descriptors where input is coming from, where is output is sent to, and all of that, and pack that in a structure. Now you have multiple instances of this structure. And then you have to adjust everything to use the structure. And be aware of this. And then another interesting thing to mention is that GDB's event loop is select/poll based. So it's a synchronous event loop. And everything runs on the main thread. And up until now, you had the input file descriptor registered there. And when input comes, it wakes up the select, and that ends up calling a callback that in turn calls readline. Readline reads a character from the input and figures out, do I have a line already in my buffer? If I have a complete line, then I'm going to execute the command that is in the line. All of that is very callback based. If I don't have a full line yet, then readline says nothing. And GDB goes back to the event loop, waits for more input. Meanwhile, the event loop continues running and processes target events and signals and everything. So now you have more instances of input file descriptors registered on the same event loop, and the callback that processes input now needs to know, okay, this file descriptor is from this channel, and that one is from that channel. The other interesting thing to mention that it might be interesting for people that are looking at the code base, you will find things like this. This is like a for each macro style macro that does like an iteration inside. But it's usually they are called all something in GDB. Like all UIs would be the obvious name, but this is called switch through because it actually switches the context to the current UI. Remember, GDB loves globals, so there's a global called the current UI. So this switches the current UI to one, and then runs the body, and then next, and runs the code. And this is found. This will be found in places where GDB needs to send output to the user, either to the CLI or to the MI channel. Actually, I should mention that there's no limit. You can have multiple consoles or multiple MI channels. Right?
They share the same state. So,
What states?
like when a thread stops, then all UIs get that thread
Right.
stop.
Wait.
Okay.
I have slides for that. Oh. Right, so where does output go, right? I knew it, that's it. So when you run a non-execution command like info breakpoints, it only displays on that where you typed it. If you do a stepping command like next, it only displays like the current line where you stepped it. Unless, but asynchronous events like breakpoint hits, they show up everywhere because it's asynchronous. You don't know why it happened. Like, it just happened, right? When you do a next, you're stepping. You're expecting to see when the stepping stops, it displays you the current line number. But someone on another console, it's just doing it for breakpoints or whatever, not even aware that the other thread is stepping, right? I'll be showing this with an example. It's easier to show. Right. Inferior output, when you run the program, if it does printf itself, it will be sent to the original TTY where GDB was spawned by default, unless you do this command set inferior TTY. This is a command that front ends typically use to redirect output to some other widget. Execution state changes, transitions between running and stopped, they always are sent to MI UIs because machine interfaces, they won't be aware of the state of the inferior always.
So when you do a step or next, there's lots of running stop transitions. Are those excluded?
No. You're talking about the internal transitions, like if a step is actually very single steps, or no, those are, you only get one running and one stopped.
But so when so you might have like step, but hey, in the middle of your sport, this breakpoint is next. In the middle of this breakpoint hit.
Right, you get a stop. You had stop, and then there's a reason saying breakpoint hit.
Right. You have two consoles, right?
Yeah.
In one console, the user presses next.
Yeah.
And that function call is going to be skipped is a long one. So
yeah.
The function is actually, the program is actually running. On the other console, you said that because it's just the next command, he doesn't see that the program now actually is running. He still thinks it stops.
Yeah.
What does he do if he does set x equals?
The same thing that would happen if you were running just one console and you ran the program in the background. You can do that in GDB, like next and ampersand.
Yeah.
The next command you type, it will say you can't do that because the thread is running.
Okay. Okay.
But that's still, I mean, again, to follow up on Michael's comment, many of these graphic consoles provide graphical feedback about the state
They do, yeah.
of the system. So if something's running, it'll show you running there, something's going on. Or if, let's say, in the GDB console, the command line console, I hit a breakpoint, and I'm also see in Eclipse or whatever my program listed out, they'll put a stop sign or whatever.
Yeah.
And so you're saying that that's not going to be recorded. If I in the console manually type break on a line number, I'm not going to get any visual equivalent.
No, you will. You will because that's
not that it's stopped yet. Just that I type the command.
That's another event. When you type the command, you mean to set a breakpoint?
To set a breakpoint.
You set a breakpoint. MI has. You're not familiar with MI, so I'm kind of pushing myself ahead. MI, because it's machine-based and it's meant for front ends, whenever you do something in GDB, there's going to be an event that's sent to MI. So you do break main enter, there's going to be an event that pops up in MI called breakpoint created, and with all the information related to the breakpoint. So the front end is always aware of this.
So that's sort of different than what you said before, where the commands will only be output in that.
Yeah, I meant when you have two consoles, imagine two consoles, but running the CLI, not one CLI and the other MI, but two consoles like CLI, right? if you do info breakpoints here, the other, imagine I'm running one console, you're handling the other one. I do info breakpoints, you don't see that I did info breakpoints, right? But if I do a continue and it hits a breakpoint, you get you see their breakpoint hit.
So actually, the 2CLI case, I can see one good, useful case for like remote debugging.
Yeah.
Debugging, code development, code.
Yeah,
debugging
that's a
remote.
typical.
Like one guy's like over in Germany, and the other guy's in like say China.
Right.
Or,
Yeah.
yeah.
Remote pair debugging.
Well, instead of you could have one, you could share the screen, but
Let's connect it to Slack.
You can do those things.
Like, the whole,
So in Andrew's pair debugging case, if one guy changes the value in the program, the other guy won't get any information.
Not currently.
But you have to have a phone conversation.
It's
you
open.
have to have more than just consoles. You have to actually have communication over.
Yeah, but then you just change the variable.
So
change the string.
What I'm saying is that you have to have.
let me show you examples. I'll be showing Eclipse. I'll be showing Eclipse actually using this. So you see the difference between old and new. It's like the multiple consoles. It was the original goal to try and see if it works, and it's useful for testing and to make sure that the coupling is correct, because globals. But the first use case this was aimed actually for in production is one console and one MI for running inside Eclipse. Multiple instances of this thing sounds nice and potentially allows other use cases, but there will be other problems to solve probably. This is all in GDB 7.12. It's not released yet. There are a few bugs to close first, but it's pretty close. And on the Eclipse side, Marco Sam at Ericsson and his team, he's the bug lead on CDT. He's working with me on this, and he just landed all the support in master this week. So it should be in CDT 9.2 in December. And there's a few details to sort out that I would like to have them sorted before 7.12 is out. One is related to the synchronization between the console and MI. And there's an event missing when the user changes current thread. If you do thread 2, enter, and MI doesn't get an event saying that the selected thread changed, which is kind of important.
Because the current thread is of course something console specific.
It isn't. It's global.
Yeah, maybe it's right now.
That's another use case, right? In the future, we could have like each.
You could make it so.
Yeah, could make it so. And there's one hard to fix problem, but it's fixable. It's pagination in queries, because GDB is single-threaded and the event loop is running. And if you hit a query, like a question to the user, GDB actually runs like a nested event loop and to continue running the events while it's waiting for the query to be responded. It has to do this because the query can appear anywhere inside your call stack. You can't just go back to the event loop and wait for the query to finish because you're nested inside the implementation of some command. And currently, when this happens, GDB stops listening to target events, to what is happening in the inferior, pitch race events. So if the program stops, GDB is not aware of it yet. It will process the event as soon as the user unblocks the query. But what this means is that some breakpoint is hit and MI is not being notified until the user unblocks
but isn't
the query.
This the same problem as when you do next enter, next with parentheses, and then you do have a query, you might not get the event. You won't get the event until after.
When you do next enter,
No,
GDB
no,
goes back to the event loop.
ampersand.
Oh, okay.
Next ampersand.
Uh-huh.
And then you have something else that like disassemble with pagination.
Yeah.
So
Exactly.
You have the same problem.
That's the same problem. Queries and pagination are two sides of the same coin. It's the same thing, basically. It's a query. It's a secondary prompt in terms of read line.
No, I'm saying it's not a problem. It's
I
the
think
same
he wants
problem.
to say that it isn't actually a problem.
No, I'm trying to say is that it is a problem, but it's a problem that's also there already, unrelated.
But it's.
Oh, I see what you mean. It's not related to the project.
Yeah, it shows up more with that.
That's true. That's a good point. So I'm not going to fix it. You had a question. Sorry, I delayed it.
Oh, that was just related to the multiple consoles thing. So I can see another use case for that is when you're not attaching to a program in another terminal, you're launching the Inferior directly, and that program itself is interactive with TTY,
Mm-hmm.
and you get your input interleaved with GDBs.
Yeah, you solve. Normally, you solve this. You solve this with this command. You can use this command. You open a new terminal, and you enter TTY, enter, and that shows you the dev, PTS, whatever. And then you use set inferior TTY and that PTS, and when you type run enter, whatever output the program does goes to that other one. What?
Or maybe not. Maybe FAQs. Maybe there should be an FAQ.
It's all in the manual.
I think the problem is that the last time we read GDB documentation is like 15 years ago.
Or 20 years ago.
Hey, demo. See if it works. I'm going to VGA, so everything's really cramped. This is Eclipse, CDT. This is an IDE. I'm not sure if people are aware. Everyone uses Emacs or VI here. I hear that some people use IDEs to debug and code. This is actually the new Eclipse. And you see here debugger console. This is a new thing. In older Eclipses, this was even not here and hidden and hard to find. I'm just going to show you new Eclipse with old GDB. And there you go. I pressed that little bug button for debugging. And here you see the GDB command line. You see there's no prompt. And up and down just moves the cursor up and down. So there's no history, no tab completion. Tab actually does a tab. So it's messy. It's the problems I mentioned before. And now new GDB. I have to go somewhere, do edit, and debugger. That was a system GDB, and I'm going to point at this GDB built here. And of course, it's not going to work because it's a presentation, right?
Maybe first apply.
There you go. It's blinking, right? Now you see a cursor blinking, and there's a prompt and print one, and then I can go up in history. And tab completion does useful things because it's actually a terminal. This here is a terminal emulator and then understands ANSI escape sequences and everything. No, Eclipse only supports one. I can do let me try next here and the code. See, the synchronization, the next stopped and the graphical part updated. What's missing is the some synchronization on the other way is missing, I think. But let me try to continue the program so that more threads are spawned. And things like selecting a different thread is not being synchronized here, I think. Oh, current thread is 2. See, I've selected 1, but GDB still thinks it's 2 because I think Eclipse is only going to tell GDB, oh, select thread 1 when I do something with the thread, like pause it or just the simple fact of clicking this thing here does not communicate with GDB. So that's it. It just works.
But if you break in
Sorry.
step 1, then it would not.
If I like a pause it,
Yeah.
like this here. Poof. Okay. So you saw that the event is displayed here, but the thread didn't change. I think. Oh, it did.
Of course
Oh,
it did.
right. Awesome.
If you change the thread from the CLI,
The
will that propagate to Eclipse?
this
Give the
if I
thread to there.
I didn't understand.
If you change the current thread in the console,
Yeah.
will it update the UI?
I don't think it will because it's missing that MI event. But thread 2 here, but nothing happened. This now it's mostly an usability problem, on a front-end problem. On the GDB side, GDB needs to learn to output the MI events that are missing, and then it's a matter of programming, right? the front end. Any questions here?
If we look at the MI output window, will it get polluted by something else, or will it just be clean MI?
I don't know how
There's
to.
an option to select in Eclipse the communication, the MI.
Do you know where it is? I don't.
Yeah, next to the stop button.
This one here?
Yeah, the drop-down box.
No, this is grayed out. It doesn't work any longer. I think it's meant to support multiple debug consoles when you have more than one, but I don't know how to spawn more than one. But I can show you the MI output on the command line. I was meaning to, then I forgot. So let me spawn a new console. So I have this magic script that does nothing but just call TTY just to tell me the current TTY, and then do not sit there doing nothing. And the reason, yeah, there you go. No, the reason it's sitting there doing nothing inside tail is because otherwise bash would be reading from input, and I don't want conflicts between GDB and bash. It's just a simple program that does nothing. I'm already taking too long. I have like 50 more slides to show. So the highlighted command just runs GDB and then spawns a new MI UI on PTS 0. What is wrong? Should be 8. Right. And there you go. Output MI output appeared here. If I let me put this always on top. If I start the program, then you see MI output appears there. That's what Eclipse is processing. And just to show you the kind of events you see on MI, for those not familiar, like breakpoint modified, library loaded, all kinds of different events that you don't normally see on the command line, but the MI is feeding that to the front end. Questions? No? Okay. Now is the part where I talk about something I'm not very familiar internally about. But I'm very psyched about this project. I think it's super important. So we're using G++. This is mainly the work of these folks nowadays. Alex doing the GCC side of the work, working on the plugin, extending it to C++. There's a C version that allows GDB to use a C compiler. And that's already in master in both GDB and GCC for a while. I'm not sure if it was GCC 5 or 6, but it's already there. And now the work is make the same thing but for C++. And the original motivation for this is that GDB inside internally has C++ parser, and the parser sucks and doesn't support many features in C++. Constructors, new calling operators, all of those things are not very well supported or not supported at all. But the GNU toolchain already has a state-of-the-art compiler front end inside the compiler. So we want to dump our own and reuse that one. And so we get access to newer versions of C++. C++ 11 brings in a bunch of C++ things, but GDB is lagging behind because no one's adding support for those things inside GDB. So the basic idea is you hand over code to GCC. GCC compiles the code as normal, and when GCC sees a symbol that it asks first GDB, what's this symbol? It sees X, and what's X, and GDB replies back the type of X and the address of X in current execution context. And then because it knows the type, it knows what begin is, so it can continue compiling, and everything else, it can infer the type of I from the return type of begin, compiles everything, it hits C out, then it doesn't know what it is, asks GDB, and back and forth. And the end result is a blob of object code that is handed over to GDB. GDB does some magic linking relocation, injects that into memory, and runs it, and done. And okay, and it's 3 question marks profit. So the first phase of the project compiles all the way down to target code, and it's not ideal because we want to make use of this also for core debugging or even to debug call expressions before running the program. And you can't do that if our program is not running, of course. But it's also useful groundwork for features like fast breakpoints and edit and continue. Because in these cases, you actually want to compile to code directly. Fast breakpoints just means instead of placing a trap in the code, you insert a jump that detours into a function that you compiled and injected inside the inferior. And this function evaluates the breakpoint condition. You break main if some expression, right? And this if some expression is currently evaluated by GDB. So the program stops, GDB evaluates the expression, and then continues the program again. The fastest way we can make this work is just to evaluate the expression inside the target code, inside the inferior. Meaning no system calls, no traps, no anything. And this requires compiling the expression and injecting something in the inferior. Edit and continue is kind of similar. You're familiar with this from other, like Microsoft has this for a long while. You're debugging code and you notice the bug, and then you edit the code, and the debugger magically recompiles the function, injects the new code in the inferior, and starts detouring jumps to the new version of the code. And you don't have to stop the program and relaunch the debug session. You just continue, and the next time the function is invoked, it will be running the new code, kind of like hot patching, right? Again, this requires being able to compile expressions down to target code. So we're aiming at supporting everything that the current parsers do inside GDB, which means we're not tackling the problem of new template instantiations. Like you have a template type argument which t, and then there's instantiations for int and float. And if you try to call a function with something else, char, it will not work because the code is not inside the inferior already. You can only call templates which are already instantiated. That's a limitation currently in the current parsers, and we're sticking with that limitation because fixing that would be very complicated. So leave that for later. And the C++ side, the libcc1 side, is, as far as I know, as far as I've heard, it's complete, and we should see a submission on mailing lists pretty soon. Alex wants me to ask who is going to review the work. Who is up to this?
When it comes to C++ and Dwarf, Jason.
Always a guy that's not in the room.
It just happens he's not here.
Yeah. Mm. Alex is okay with becoming a maintainer of this. Should make sense to me.
Yeah, I know.
I need to move along. Interesting things. He managed to make it work. Things work like in GDB. You can inspect private members of classes. Class A has a private field B, A.B, enter, and prints you B, but it's private. But you're calling the compiler, and the compiler is going normally to reject that access to B because it's private. But he pulled some magic strings and made it work using friends. He made basically the code that's injected in the inferior is friend of every class. But the neat thing is that this does not affect template spine and how do you call this when a template? That's a correct term, right? Template overload resolution. If it would fail because it's the field is private, it will still continue failing correctly. This magic thing does not break that aspect of it. So it's yeah, it's magic. We hit a bunch of problems with missing the bug information in this project. Things that GCC queries GDB for whatever information, and GDB does not know this information because it's not in the debug information. Some of this is bugs in GCC. Some of it is just lacking someone adding the code to output some standard Dwarf. And others are like missing Dwarf features that need extensions. So this is kind of why you see Alex pushing a bunch of Dwarf information fixes recently. On the GDB side, we're still a little bit further away from being done. The changes on the GDB side are much larger. The branch, there's a branch on sourceware. You'll find the, put the link somewhere. Back. There's a wiki page, and somewhere in the slides I put the link. And it involves changing so much inside GDB, like the Dwarf reader, the whole type system, and simple tables. It's maybe not useful to go over all of this. But it's eventually going to be complete and submitted probably next year. But we would still like to have the GCC side of the work pushed upstream and ready in version 7, so that the next releases of GDB can make use of GCC 7 already, instead of waiting for another year before this is released inside GCC. I need to move faster. Okay. Okay. So one thing I mentioned before that we would really like to have would be to make this all work with core file debugging, and we kind of toss around the idea of a Gimple interpreter. I don't really know if it makes sense to stop compilation at the Gimple level and interpret Gimple, or to stop it at RTL level and interpret that. I'm really not that familiar with GCC's internals. but it kind of makes sense to me to stop compilation at some IR level and interpret that. And it would be something like you interpret like additions and operations, and whenever the IR needs to read memory or some register, that would call back into GDB, and GDB would serve the result back to the whatever's interpreting the gimbal. I think it would make sense to have this inside the plugin. So that's closer to GCC.
So should we compile into Dwarf or something like that?
Then you have the problem that Dwarf expressions don't express everything, and you have that mismatch. You're going to end up stumbling on, Dwarf can express this. Now we need a Dwarf expression. I think if you use some IR that's already native, you bypass these problems.
So there's one problem right now, even without doing this, that I can think of is what happens if somebody decides to write an infinite loop? How do you handle that case?
Control-C, exactly.
No, I'm not asking, does it go back into the embed loop then, or do we?
You mean the interpreter?
Yeah.
Something you would register. Yeah. You would register some SIGINT handler or something. You press Control-C, and that stops compilation, returns an error back to GDB, and GDB throws an exception.
What is the plan for function calls? So if you don't have a leaf diagram, but the expression involves calling a function.
You mean in the interpreter?
Yes, in the interpreter.
Probably you would.
To be seen.
Yeah. If you call a function, then you just say you can't do that. Just like currently when you're debugging a core, you can print globals and registers, but if you try to print some function, then it's going to say you can't do that without a live process. And the interpreter could make use of that and start simple and support simple expressions, and if you find something complicated, just bail out. And over time, I'm aware. I'm not. Yeah, I'm aware. I'm aware. I'm not sure at what level they do the interpretation.
Well, LVM IR. In LVM it's easy because they have their IR values very different. So they have the parser which compiles to IR, and then at IR they have an interpreter that tries to interpret the IR. That may work, but it's good. If it doesn't work, they use the JIT.
Okay.
And execute the interpreter.
Yeah. Okay, so we have a proof of concept. We know it works. Oh, another topic. Local remote feature parity. I haven't checked the time. Sheesh. No, I have 2 hours for me. Okay. All right, so local remote parity, this is about GDB and GDB Server. GDB, when you do debugging locally, natively, you type run, and it's GDB is handling the ptrace calls itself. When you're running a program in some other program machine under GDB Server, of course, GDB Server is handling ptrace itself. And the code to handle ptrace should be the same, right, in both sides, but it's not. GDB and GDB Server have different implementations of all of this. The code is very similar. Over the years, we've tried to make it look more and more the same, but it's still different implementations. And in non-trivial details, they are very different. So the goal is, of course, to get rid of one of those. Because GDB Server already needs to work without a GDB around, it needs to be more decoupled from GDB, obviously, because it's a separate process in a separate machine. It's easier to grow GDB servers and then drop GDBs. And even more than that, GDB Server supports features that GDB doesn't, which are very hard to implement. So we wouldn't want to make the same effort again on GDB because, for example, trace points are already there. So let's use this one. Back in 2014, I think, I did a presentation similar to this one in FOSDEM. And this is the slide I presented, one of them. and where it showed there are features that GDB supports, GDB Server doesn't, and others that GDB Server supports and GDB doesn't. But nowadays, we're getting close. Of course, there are more details. These are the bigger ones. Catch syscall. You catch syscall and open, enter, and continue. And when the program does syscall open, it traps. It's like a breakpoint, but it's catching a system call. Fork following. I mean, you do set follow fork, set follow fork child, or set follow fork parent, and set detach on fork off. With these commands, when you continue programming, the program forks, GDB continues debugging both programs. And if one of them execs, then you're debugging both programs and each of them with its own symbols. You can't do that in GDB. You couldn't do that with GDB Server, but now you can, since recently. Thread names was something else. That's more minor. The last missing feature is globbing parameter expansion. This is related to starting the program with a shell. I mentioned all of this. Minor detail that GDB Server do not support showing the thread name here. This is foo. This is you can manually set names of threads, so you can track which thread is which easier. And the Linux supports programmatically setting the name of a thread with pthread set name. And GDB can extract that name and display it for you. So if your program does, I have a thread which is a worker thread, and you do pthread set name worker. Inside GDB, you do info threads, and you immediately notice which one is the worker because the name will appear there magically. Didn't work with GDB Server. Nowadays it does. And getting there. Another neat feature that Gary did most of this work, or all of it, was the target sysroot. This is an extension of Ulrich's work on the remote sysroot. This is about retrieving binaries off of the target system. Instead, when you're debugging remotely, instead of copying the sysroot out into your hosts and point GDB at that for symbols, you could tell GDB, just fetch them directly from the remote side. And it's very convenient, but this didn't work transparently, because if you put that set sysroot remote in your GDB init, for example, when you did native debugging, then it wouldn't work, because it would try to do something with a remote end that didn't exist. So we generalized this. Now there's a target sysroot, which works like remote when remote, and uses a native local file system when local, and works well enough that it's now the default. Now the nice feature is when you do attach to a process natively, you just do attach some PID, and GDB figures out which is the program that's running the process and loads the symbols, everything magically. Didn't work with GDB Server. Now it does. Skipping things. Right, and starting shell is one of the remaining features that would be nice to have. This is GDB, when you do run enter, it doesn't actually spawn the program directly. It spawns the shell and the program and the arguments you specify. And the reason for this is shell expansion and variables. So silly example is debugging ls and doing run and with a star. If you run through the shell is going to expand the star into the list of programs in your current directory. These are the files. And with GDB Server, it just passes the star as an argument directly to ls, and ls, of course, doesn't find a file named star. So we need to make GDB Server actually spawn programs through the shell as well. Ideally, because we're not very keen on duplication, we have plenty of it. We would like to share the current code inside GDB that makes this and use it in GDB Server as well. Makes it longer to have the feature, but it's better long term to do it right from the beginning. Skip that. And skip that. All right, container debugging. Pretty much the same things that I mentioned with the target sysroot. The rationale for doing this in the past year was actually the container use case. Gary was focusing, and still is, focusing on this area. And we realized that debugging a program that's running inside a container from outside, it's pretty much the same thing as debugging remotely. Many similarities. And the access to the files running inside the container, if we see it like the remote case, it's basically the same thing, right? So we, alongside the target sysroot work, we made GDB be able to retrieve the files from inside the container. And containers have this neat, interesting thing, which is that they run, the file system inside the container can be in a different namespace. The file namespace, right? There's the mount namespace. There are other namespaces like PI. So you can ask the library, get me the TLS address of this variable, and the library will look inside glibc's internals and figure out the addresses of things and return back whatever GDB needs. The problem with containers is, because this loads inside GDB's address space, you don't want to do that because there's a security issue there. You can't trust whatever's inside the container. We're working on a solution for this. And this will also allow cross-core debugging because this is built alongside glibc, means it's very tied to the current build of glibc. So you can't use libthreadDB to debug an ARM core on an x86 machine. We're working on a solution for this. It's based on, instead of loading a library inside GDB, you do some magic. You interpret something, and that something is built inside pthread.so, libpthread.so. So instead of running code inside GDB's address space, you interpret something. This something is based on Dwarf expressions. It's very, very cool. So please go attend that talk. What time is it? Okay. I'll just skim through all this very fast. So another work we were doing is merging allstop and nonstop. So allstop stops everything, nonstop stops one thread. We want to have a middle ground, be able to create groups of threads, and say when this breakpoint triggers, just stop this group of threads.
So did you find a meaningful way to characterize threads?
To what?
To characterize them. Like, how do you create the group of
You
threads?
currently, this is still in a prototype phase.
Yeah.
And the idea is to make it possible to programmatically, like with Python or something, you create in a script. Because the grouping will be specific to your program, you would want to call back into Python and say, my worker threads have this whatever property, and your Python code will be aware of this property and create groups for you. Well, we're not there yet. This ideal triggers a bunch of problems and work that's been going on for a couple of years already or more. And one of them was that thread numbers in GDB are unique, are global. Here, there are multiple processes here, but you have no idea. This is process 1 or 2, whatever. You can't say because this number space is unique, it's global. So nowadays, since 7.11, you have inferior dot thread number. So a thread number is no longer unique. You need both. You need the inferior number and the thread number. So much more organized. Supports ranges and using stars to say all threads of a process. Another thing that we changed related to this is when you see this in GDB, you have no idea which thread hit the breakpoint or got the signal. And running multi-process and multi-threads use cases through this expose this problem. Now we actually say which thread it was. Right, and we're trying to come up with some syntax to specify, to be able to specify the groups in a flexible manner, like unions of things, unions of threads, unions, say, I'm going to show the example on the top, like all threads of process 2 and whatever is not running on cores 3 to 5 and all stopped. Common means plus thread 1.3. So we're trying to come up with some syntax to express this. This is the tentative spec currently. It's subject to change, but right, I'm going to skip all of this. So I mentioned before being able to specify threads in breakpoints, say what stops and what runs. So there will be syntax for that. So break at main, but when it triggers, just suspend all the threads running in process 3. Right. And this is the front-end side, the user interface aspect. And while you're experimenting with the user interface, you stumble on problems in the run control side of GDB. And you want to experiment with things, but they don't work. So you kind of iterate between fixing the actual code that makes run control work with experimenting with the user interface. And it's funny because, oh, it's empty. That's a slide there. That's an image. Okay. Oh, man. Okay. So it's this over the 2015-16, this stumbled on so many problems, fundamental problems like more libthreadDB problems. We were using libthreadDB to iterate over getting the list of threads in the inferior, and you can't do that while some threads in your program are running, because libthreadDB is reading a linked list and following pointers, and while doing this, if some other thread exits, then you're changing the chain while GDB is iterating, and it would happen that occasionally, like once in a blue moon, GDB would get in an infinite loop somehow inside libthreadDB, and the reason was this. So nowadays we don't rely on libthreadDB anymore for listing threads. We use the proc file system instead. A very fundamental change this required was the how does GDB know that a trap is a breakpoint hit as opposed to a random signal or a single step finishing. So the kernel, when one of these things happen, reports back a sig trap, and GDB just tried to infer from the address the thread is stopped at, whether it was a breakpoint or a single step finishing. And the reason this was a problem is that on x86, when a trap is reported, the PC is actually after the breakpoint. So GDB or debugger needs to unwind the PC back. And there are cases where the breakpoint was placed on top of an instruction that's 1 byte long. So you can't really tell if you plant a breakpoint, a thread is running, trapped on the breakpoint. Meanwhile, GDB removes the breakpoint. And then the event comes, and GDB processes a sig trap. But now the breakpoint is no longer there. So GDB no longer knows that the trap corresponds to a breakpoint. And the result is GDB would not correct the PC, and next time the thread is resumed, it would crash. So nowadays we rely on a kernel feature that in the sig trap SI code field of a sig info, it reports the reason for the sig trap. And for many years, I thought that the x86 version it fills that SI code incorrectly. So if it's a breakpoint, it says something else. And I just assumed it was broken for many years until I stumbled on this, and I'm like, oh my god, no, I need to fix this. And when I looked at the actual code in the kernel, I realized that the values are all wrong. If it's a breakpoint, it says single trap, a single step. If it's a syscall, it says breakpoint. It's all backwards, but all of them are distinguishable, so it's useful. Yeah, yeah. it's each architecture has its own copy of the code, so they'll differ. Yeah. Okay. Okay. I have no idea. Yes, 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 yes. Because this is deep inside kernel code, code that handles the exceptions, and then that translates the exceptions to a signal. It does do signal, and then the signal number, and then the SI code as well in the function call. And because each architecture does this differently, some of them will say SI kernel, some will say SI trap, meaning breakpoint. Yeah, that's a problem.
And what about other operating systems?
Other operating systems don't support nonstop yet. This mode of leaving threads running while others are stopped. So once, I know you're asking me this because of AIX.
No, I actually did like BSD back on.
Okay, so yeah, so this first requires you to hack on the run control code in the backend of GDB that does the ptrace calls, and to support this mode of operation. And once you get that, then you'll notice whether you need something like this or not. I don't know. Probably you will. I know that other ptrace implementations are able to report these events in a different way, not through signals, for example, like a different event. So it will depend. All right, so this is all work in progress, and it will be done at some point. It still requires work on the run control side, and then finalizing the specification, the user interface aspects, and then MI will need to be extended as well. Hope to have this done sometime this year, next year, and I think that's the last topic. And GDB's own conversion, C++ conversion. And why? If you look at GDB's code base, it's already poor man C++ in many ways. We use exceptions. We use try catch and throw exception, things like that. We use virtual subclasses with virtual methods, but we actually maintain the function pointer table manually. We do RAII, but instead of using destructors, we use something very similar to attribute cleanup in GCC, but we do it manually. We call a function called make cleanup, and then at the end of the scope, we need to remember to do cleanups, and if you forget, then you leak. We use templates. We use VAC that originally came from GCC, thanks to Nathan. It still has a legacy there. Yeah, so we actually want to just use a compiler to implement these features. And well, this past year, we went through from many discussions over the years about switching to C++. Several proposals, they were all shot down at some point. The latest was started by Tom Tromey a few years ago. I was personally against it for a period, and then I switched my mind. And I kind of killed that effort. So as a penance, I led the effort. So yeah, took a year basically, but this past week we officially dropped support for compiling GDB as a C program. It was already C++ by default in 7.12, but you could still pass disable compile with C++ if you wanted a C compiler, but nowadays in master you cannot. So we're free to use C++ features finally. We're not using them yet, but we will. Yeah, so that's what exceptions looked like a few releases ago. We had this try-catch macro, And when it raise an exception, this would magically, this is seek jump, long jump inside. Then you handle the error here. Yeah, nowadays it's closer to C++. Now you have a try catch, and the reason for this change, overall massive change all over the code base, was to make it possible to define these macros in terms of C++ try catch, to experiment and see what the problems, what problems would show up. So you see, like, you went from this to this, and in the future to that. This involved a bunch of casting problems. Unlike the GCC conversion, we tried to originally the good idea was to model on the on the GCC conversion, which used the warning, the C++ compat warning, and relied on that, and actually was developed alongside that. But it was limiting, and so what we did was, first we aimed at compiling GDB with a C++ compiler, not by default, but with a configure switch, but with a hack, with the f-permissive hack. This allows you fixing glaring C++ problems, like you have a structure inside another structure. In C, most structures are in the global namespace. But in C++, this actually means a nested structure inside another one. So you have to move the nested structure outside. And then the code compiles with C and C++. You fix all of those problems, and then you end up like, I don't know, maybe 2,000 warnings that you filter, that we disabled them by using f-permissive, like casts and conversions between ints and enums. Just, speedier to get GDB to actually compile with the C++ compiler. Then we spent a few months actually cleaning all these warnings up. Right. Another interesting thing that we had to fix was that GDB would throw exceptions from inside signal handlers, which is not a valid thing to do in C++ and not a good idea to do in C. GDB needed to do this in some cases where it would block inside the system call, and now you need to Control C to interrupt that. The way that GDB would do that was to seek long jump from inside the handler. Nowadays it no longer does that. Right, so since last week we are C++ only, and now in the future we're going to actually make use of this. I have a branch that converts the target ops structure into a real C++ class. It requires touching every target.
How do you use a native try catch now?
How do you use what?
Native C++ try catch.
How do you use? No, you can. Not yet. So you cannot yet use it, because the macros are mapped to try catch, but in addition take care of cleanups. So as long as you have the manually managed cleanups, the make cleanup and the do cleanups, you need to use the try catch macros. Otherwise your cleanups will not run, right? So you had two ways to do this. Either like a flag day, where you just convert all cleanups to use RAII, or we use the macros and allow a smoother transition.
But I think there is another issue if you don't want to cross the read line.
Yes, that was a problem. Yeah, that's a different problem. Yeah. So GDB uses readline using the callback interface, which means it listens, puts the input file descriptor in the select, and waits for events, and the select is waiting for input and target events and other events. When input comes, GDB knows, oh, it was the standard input file descriptor. Then I call readline, and readline reads data from input. And if it has a whole line, then it calls into GDB, and GDB executes the command that was typed. And if this command has an error, this means that GDB throws an exception. and all the way back to the event loop again. But this exception is going to cross readline. You're inside readline. And readline is not compiled with -f exceptions. It's a C library. If you're lucky, your ABI has this by default, like x86, 64. But other ABIs, other architectures, they don't. And what happens is the GDB just aborts because you reach a foreign frame. The unwinder is not aware of that frame and just drops. So the solution is we wrap crossing through readline. The readline callback calls into GDB, and GDB puts a try catch, runs whatever code. If that throws, that's caught in that try catch, and then you have to long jump across readline. Yes, that's how it works. Yeah. And finally, I said I would be taking very long. I'm sorry. Yeah.
About the C++
Yep.
project, does GDB community have a plan for obsoleting internal GDB C++ parser?
There's a goal, there's a wish for that, but there's no material plan.
So for now, you are planning to maintain both parsers.
Yeah. We would like to at some point be able to rely on GCC for everything, but it's going to take years to get there. So we have the core debugging problem to solve. We have the cross debugging problem. It's the same problem with interpreting instead of running code, the Gimple idea. We have to solve all of that before being able to drop GDB's internal parsers. So it's going to take a while. There's no plan other than we would like to. Anything else?
Do you know what is the experiment with GCC parser when GDB don't have the full unwind, full debug info? Does GCC full fail nicely, or is it usually ends up crashing?
Well, I'm not sure I understand what you.
So if you try to evaluate it, compile something, and GCC not able to supply full type information because debug info is missing, or just
It will just fail.
Is it fail nicely, or is it just crashes?
No, it fails nicely.
Okay.
It's just like when you compile and normally using GCC on a command line, and your code has a typo. It's referencing some variable that doesn't exist. It's a compile error.
Okay, but
it's a compile error that GDB reports on the command line. Yeah, unless the compiler ices, then then the whole thing goes down.
Do I remember correctly that GDB can support several targets?
Yeah.
One binary.
Correct.
But GCC doesn't do that, so you
Nope.
would need one lib C++, one lib
Yep.
C1
Mhm.
for every target
Yep.
that's supported.
True. So GDB loads GCC as a plugin at runtime with DL open. It's not linked to the compiler. And there's this processing between the triplet. There's some magic, some awareness of some path lookup awareness. Like if I'm compiling for ARM Linux, the triplet is going to be ARM Linux GNU EABI or something. And GDB will look for the ARM Linux GNU ABI -GCC. I don't know how it's called, or the directory containing that binary, and then looking up for the libcc1 library there somewhere in that file system, that tree of binaries related to GDB GCC.
Nowadays, we just first have to trigger it for some options concept for the existing one. We not use a public trigger to locate which.
I think we do.
I mean, we just pass the public trigger.
Huh?
Determine which kind of options we pass to the libcc1. But
But
we do not decide, we do not use a public trigger to decide which libcc1.
I think we do.
Right?
No?
I-
Or maybe we should, and we don't, but we should. I was pretty sure we did.
Can you unload that plugin?
Yeah,
So you can load a different version?
but I think, yeah, the idea is you should be able to do that, but you do run into problems with, no you don't. I was going to say do a graceful cleaning up, but no such problem, I think. I'm not sure.
Can you load multiple copy of them? If
No.
you debug two remote application on
No.
time?
No, not at the same time. You would have symbol collisions, and one would override the other one.
And how do you set things like different compilation options that would be needed?
Yeah, so
So ARM has hundreds of different modes that you might want to build in code.
so I believe we look up. There's this attribute in Dwarf that encodes the command line that was used. We parse that, and we reuse that. And then there are default options that are encoded inside GDB per architecture. And then there's an escape hatch, the command line switch you can use to override all of that if you need. Yeah,
The thing is, every file may be built slightly differently.
it's true.
Some may have more relaxed.
Yeah, kind of assume that it's like you're injecting code in this context and stopped inside this frame. So we are going to use the architecture of this current frame, and say if the frame API is marked in some way that GDB is aware of, say if it's a soft float or hard float or something, if GDB can infer that from the GDB arch object associated with that frame, then we could make the plugin, pass the right arguments to the plugin. I'm not saying we do that, but I think we could. But somehow GDB would need to be aware of the properties of the context.
One more question on the GDB project. And, well, the real question is how much we can use for political reasons and for licensing reasons other compiler infrastructure or VM.
I have no idea.
The specific question is, do the community consider using Clang or LLVM instead of libcc1 or GDB parsing? As far as I understand, in this particular specific case, licensing is not an issue because we are using LLVM, which has permissive license in the GNU project,
Right.
not the other way around.
Well, that touches politics aspects, and that you better ask FSF. But
Political, not licensing.
yeah,
It will be political.
There's a technical reason for using GCC, which is you're going to mainly when you're using GDB, you're going to be using with GCC compiled code. When you're debugging with GDB, it's reasonable to assume that you're going to be debugging code that was originally compiled with GCC. You can use it with others. The thing I'm trying to say is that we want to support every kind of extension, new extension, everything that GCC supports. And using Clang, sorry?
And GC supports more extensions.
Yeah, I mean, if I'm debugging, speaking from a GNU perspective, right? I'm debugging code that was compiled with GNU compiler, and I used attribute something and some extensions that are GNU specific. If I'm going to debug my code and use this feature, I would want this all expressions that I pass to the compiler to be exactly parsed in the same way that the compiler parses. If I'm compiling with GCC and then when debugging I use Clang to parse the same expressions, then I can potentially have a mismatch here. So at least for starters, we want to use GCC.
Yeah, I think that if somebody wanted to do work,
yeah.
do this all using
So
LLVM,
you could.
What GDB to do is look at the DWAT producer to decide to talk to Clang.
Yeah.
Or Clang code and to talk to GCC for GCC code.
Well, there are also some languages that Clang supports that GCC doesn't. So there is a technical reason which GDB might want to use Clang. So like not as far as I understand, libc1 not only enables C++ parser, it also enables Imperial Fortran.
No, it's C++ specific, C and C++.
Just C and C++.
Yeah.
Each language has to be added by hand, so it's not. You don't suddenly get everything GCC supports just through libc.
In theory, you could write a plugin using the same plugin interface, and the interface between GDB and GCC is through this defined interface. It's API stable. We don't change interface, and in theory, you could implement that interface using Clang on the other side. I have no idea if there's like an impedance mismatch there, if it makes sense, if the current interface makes any sense for Clang. It may not, but it was built and designed for G++. In theory, it's not specific, but I don't know.
My point is that GCC and GDB supports quite a much more architecture than Clang. So if you would go with Clang, then you don't support a lot of architecture. That is one side. And the API inside Clang, what can be used to do this JIT compilation, isn't stable in any sense. So it not changes too often, but it is not a stable API you can rely on. So.
Right. We had to start somewhere, and we have a preference for GCC, so that's what we did.
And we happen to have a compiler. And of course, I mean, you can use LDB, which does the same thing.
Yeah. Yao wants to show some nice things he's been working on. Few. Okay. Okay. The other guy said it was going to be fast, but then it took 2 hours, right?
Yeah, but 2 hours is fast enough.